Welcome back to another chemistry video. This is our second example of solution stoichiometry. So we are going to make a balanced chemical reaction. We're going to put our puzzle pieces below that chemical reaction. Then we're going to string our puzzle pieces along in one big calculation. And that is how you do stoichiometry, son. All right, let's try this out. In an experiment, 10 milliliters of sulfuric acid reacts with 15.9 milliliters of 0.150 mole per liter potassium hydroxide. Calculate the amount concentration of sulfuric acid that we had to begin with. Okay, no problem. We are going to assume that this is going to totally, because sulfuric acid is polyprotic, we are going to assume that this is totally neutralizing the acid, just for this one example. Now, it will be way more clear on an exam, or it will be way more clear on an assignment or a quiz, but just right now we're assuming that we totally neutralize all of the acid in that polyprotic acid. So let's try this out. First step is we have to make a chemical reaction. All right, we're going to take our H2SO4 aqueous, and we're going to react it with potassium hydroxide aqueous. This is going to make, well, we're going to get the K and the H's are going to swap. So we're going to get K2SO4, potassium sulfate aqueous. And we're going to get H2 with some OHs. Well, this is an acid-base reaction. In an acid-base reaction, or in a neutralization reaction, that's our double date partner swap, where somebody cries at the end. Liquid. Perfect. Not perfect. We don't want anybody to cry, but you know, whatever. At the end of the day, that's what happens. So we have sulfuric acid with KOH makes K2SO4 and water. Let's balance this. Looks like we have 2 potassiums. We need 2 of those. And because we have 2 OHs, we need 2 OHs. We have 2 hydrogens at the front, 2 hydrogens at the front. Perfect. That's what I like to see. So now that we have our balanced chemical reaction, what we're going to do is we're going to put our puzzle pieces below it. In an experiment, 10 milliliters of sulfuric acid, 10 milliliters H2SO4, reacts with 15.9 milliliters KOH, and the concentration of the potassium hydroxide was 0.150 moles of KOH in every 1 liter of KOH. Perfect. Calculate the amount concentration of sulfuric acid. So we're looking for the concentration of sulfuric acid. Well, if we want to relate the amount of one thing to the amount of another thing, we have to use our molar ratio. So off to the side, I'm going to put our molar ratio. Our molar ratio is always unknown over given. Our unknown is the sulfuric acid. So 1 mole of H2SO4 will react with 2 moles of potassium hydroxide. We have all of our puzzle pieces. We are good to go. Nothing can stop us now. How do we always start? We start with what you want. Absolutely every single time we start with what you want. Start with what you want. Start with what you want. We're looking for concentration. Concentration is measured in moles per liter, and we're looking about sulfuric acid. So that's what we're looking for, concentration in moles per liter of sulfuric acid. Well, what has first, this is where we start to get a little bit complicated. We're looking for two units now. We're looking for the moles of sulfuric acid in the top, and we're looking for liters of sulfuric acid in the bottom. Let's start with moles of sulfuric acid, and let's see if we can end with liters of sulfuric acid. So what in here has moles of sulfuric acid? Anywhere in here, where do you see moles of sulfuric acid? Well, I see moles of sulfuric acid here. I see moles of sulfuric acid in our molar ratio, so that's what I'm going to start with. 1 mole of H2SO4 will react with 2 moles of potassium hydroxide. So that's the unit that I want to keep. But I want to get moles of potassium hydroxide. So what do I have to multiply by? Well, I have to multiply by the concentration of potassium hydroxide. 0.150 moles of KOH per 1 liter of KOH. Perfect. So what's happening here is my moles of potassium hydroxide are canceling out. I'm left with liters of potassium hydroxide. Where else do we have liters of potassium hydroxide? Well, I know that we used 15.9 milliliters of potassium hydroxide. That's pretty close to what I want. 15.9 milliliters of potassium hydroxide. So liters of potassium hydroxide and milliliters of potassium hydroxide will cancel out. This is pretty good. We have our moles of sulfuric acid. That's what we wanted. The only other thing we need are liters of sulfuric acid. Well, I see liters of sulfuric acid right here. So let's add that to the bottom of this last unit conversion. Let's add 10.00 milliliters of H2SO4. Now, I want liters of sulfuric acid. I have milliliters, but hopefully you'll notice that the milli and the milli cancel out. We are left with moles of sulfuric acid on the top and liters of sulfuric acid on the bottom. Fantastic. This is exactly what we wanted to see. When I put this into my calculator, I go 1 times 0.10 or 150 times 15.9 divided by bracket 2 times 1 times 10 end bracket. When I put this into my calculator, I'm going to end up with 0.119 moles per liter H2SO4. Fantastic. That's exactly what I want to see. I've got moles of sulfuric acid in the top, and I've got liters of sulfuric acid in the bottom. We are good to go.